Assalamualaikum warahmatullahi wabarakatuh. We meet again. So this is actually a discussion on example for the three-phase systems. So without further ado, we start with example one. So determine the phase sequence of the set of this voltage. So as you may recall, for three-phase we have two type of sequence: the positive and negative. Okay, so for the positive should be the rotation should be A, B, C, while for the negative sequence, the rotation should be is actually should be else from this A, B, C. Okay, so we start with the this system. So it's easier to plot, okay, whether to determine whether it is positive and negative. It's easier for us to plot the phasor diagram for this system. So just a rough plot, okay. So VAN positive 40, so meaning that this is your VAN. VBN is negative, meaning that it's down under here. So this is your VBN, while your VCN is positive 160 degrees. Okay, sorry, maybe it's like this 160. So as you can see, if you put your eyes here and then the face is rotate like this, so you will see that the rotation is start with ABC, or it may be start with BCA. Okay, BCA, but as you can see, if you repeated this one, BCA, so you can see that we have the sequence ABC. So this one is actually a positive sequence. Okay. Next is actually on the second system. So the second system, so you start with this one, so negative. So this one is your VAN, and then you have your VBN positive. So meaning that you have like this. So this one is your VBN, and the last one is your VCN, which is negative 130 degrees. So if you put your eyes here and then it's rotate, so you will see that this is ACB. And if you rotate is ACB, you will not have the what you call sequence ABC, right? So it will start with ACB. So this one is a negative sequence. Okay, that's all for example one. Okay, next we go for example two. So example two, a positive sequence three-phase voltage source connected in balanced Y connection has a line voltage of VAB with with a value of 208, okay, angle negative 30 degrees, and this VAB is a VRMS. So determine the phase voltage. Okay, so this is the solution for example 2. So VAB is given 208 VRMS. Determine the V phase in Y connection. Okay, so we know that for Y connection, V line relationship with the V phase is square root 3 multiplied with V phase, and the angle should be leading by 30 degrees. Okay, so right now the question give you the information about the V line, which is a VAB. Okay, so you just substitute V line with these values. So, and then based on these equations, okay, we finally will obtain that our V phase is actually 144 volt with an angle of negative 60 degrees. And since these values is actually, we refer to the VAB, meaning that this value also will represent the VAN. Okay, so your VAN or V phase is 144 with an angle of negative 60 degrees. To calculate the phase B, okay, since this is a balanced system, so the magnitude is still remain the same, 144 volt, but the angle should be have a different angle from VAN by 120 degrees. So meaning that your VABN should be 144 with an angle of negative 180 degrees. The same case goes to the VCN, okay, where the VCN should have a phase difference between VBN by 120 degrees. So your VCN is 144 with an angle of 60 degrees. Okay, so if you plot the phasor diagram of this three-phase system, you will have that based on this angle difference, you will have that all the phase are balanced, and with the magnitude of 144. So we maybe put this symbol to say that this is actually equivalent values, and the angle phase is actually 120 degrees different for each phase. Okay, this is also 120 degrees different. Okay, that is for example 2. Okay, so this is the example 3 from the slide. A balanced Y connected load is supplied by a Y connected source with a phase voltage given VAN is equal to 240 volt RMS. So if IA is 2 with an angle of negative 20 degrees ampere, find the phase and line voltage and also phase and line current. So from that, sketch phasor diagram and assume that the phase sequence is positive, meaning that the phase is actually ABC, okay, rotation. So the Y connected load, so I have already what you call draw it for you. So this is your Y connection ABC, okay. And since we know that the voltage line and voltage phase is not equals in Y connection, so we need to have to use this equation, right? So V line should be larger, okay, V phase, and then the angle must be 30 degrees leading. Okay, so right now the V phase is given 240 volts. So this is VAN, but since it doesn't give you any information which phase is the reference, so we assume that this VAN is the reference. So the angle is set as 0 degrees. Okay, and then from that we can start to analyze or to calculate the line voltage VAB, for example. So VAB, as you can see, we just multiply with square root 3, and then the angle should be 30 degrees leading from the V phase. The same case goes to VBC. So the same magnitude, but the angle should be out of 120 degrees different between the VAB. So this one will become negative 90 degrees. And same case with the VAC, where the angle here is 150 degrees. So if you plot the voltage line, okay, the line voltage, so you will have like this, okay, VAB, positive sequence, VAB, VBC, and VCA. Okay, if you want to plot the phase voltage, so I think this one is your phase VAN, okay, and then this one should be your VBN, so should be shorter, okay, should be shorter than your V line, and last one is your VCN. So this should be 30 degrees different between both phase and also line. Okay. Okay, and then for the line current, so for Y connection, the line current and phase current is actually the same for Y connection. So meaning that the I, so from that we can just calculate the current. Okay, so IA, which is IA is actually your V phase and also V line. So the magnitude is 2, angle negative 20 degrees. And IB is also the magnitude is same, but the angle should be 120 degrees difference. So this one should be negative 140 degrees, and this one IC should be 100 degrees. Okay, so if you want to plot, so this is the plot of the phasor of the line current. Okay, so that is for the example 3. Okay, now we continue with example 4. For the circuit shown in figure below, find the line and phase voltage and line and phase current. And then sketch the phasor diagram. assume the positive phase sequence and VAN as a reference. Okay, in that questions, they should actually mention that the 416 volt RMS is actually a V line. Okay, so please be noted that the values is actually V line. Okay, so if VAN is used as reference, meaning that the phase VAN should have a 0 degrees. So the line voltage, okay, VAB, VBC, and VCA should have like this. Okay, so meaning that VAB is actually must leading the VAN by 30 degrees. So you can write down your VAB as 416 angle 30 degrees, and VBC is 416 with an angle of negative 90 degrees. Okay, why? Because you know that this one is actually come from this one, 30 minus 120 degrees. Okay, and then this one is actually 30 plus 150 degrees. Sorry, 120 degrees. Okay, so that is your V line. Okay, and for your V phase, so Vn as the reference, so the angle is 0, and we know that the relationship between V line and V phase for the Y connection is not the same. Okay, so 1416 over square root 3, so you will have the values which is 240 volt V phase. So this is for the VAN, and for VBN is still the same, but the angle is 120 degrees different. The same case goes to the VCN. Okay, next is actually to calculate the phase current. Okay, so for Y connection, the phase current and line current is actually the same. So, but okay, so we can calculate by using this equation. Why I'm using V phase and not V line? Because we know that load here, if I draw, okay, if I draw, so this is actually your VAN and this is your load. Okay, so mean that to calculate the current IA, what I need to do is actually to calculate what is to use the voltage across the load. So right now the voltage across the load is VAN, not VAB. Okay, not VAB. So I need to use VAN instead. Okay, so that's why this one must be V phase. Okay, so you substitute the V phase, which is 240 volt with an angle of 0, and then the load is 50 minus J50. So you calculate, you will have your IA is 3.4 angle 45 degrees. Okay, and also IB, same magnitude, and then the angle is should be 120 degrees different. The same case also goes to IC. Okay, 3.4 with an angle of 165. So that is for example 4.